for the school to pick up something. Yes.
Hello? Are we back as normal, or are we going to have Aneta?
Yes, please.
Are we continuing as we stopped, or you're going to have fancy things happen?
No, we will try the 3-channel connection.
Oh, okay. Is this is not 3-channel yet?
That's 1 channel.
Okay, that's what I thought, yeah.
And we will see. So here everybody will judge whether there will be some improvement or what.
I'm sure there will be a lot of improvement.
Okay.
If we improve too much, they won't want me to come up there.
No, you're most welcome anytime.
Well, wait till they see me with 3 channels on.
Okay, let's see. I just think I'm 3 channels.
I think you have to αυτοί κάνουν dial-up. Okay. So, Aneta.
Yes, please.
Did you collect the comments from my friends there?
We will collect them at the end.
I really will appreciate if I have 3 lines, 4 lines from each with all the comments.
Do it now while you are.
That's right. That's right.
I'll give them some.
That's very good.
If there was anybody who wanted this connection to fail, her name was Aneta. Okay?
Okay.
It's connected. It's connected.
Ναι. Χαμήλωσε το λίγο.
Τώρα δεν γίνεται.
Όχι, εντάξει, δεν έπαιρνε. Άστο, δεν με ενοχλεί. Γιατί δεν βάζεις την εικόνα τη δικιά μου επάνω στην δεξιά, στην αριστερή γωνία επάνω, αν γίνεται.
Μισό λεπτό.
Αυτό ήταν multi-point.
Τώρα μην γίνεται.
Τέλος πάντων.
There.
Aneta, you know how you look from here? Like a car dealer in a casino.
I was just saying it looks like sharing some tissue, toilet tissue.
Is this how good the comments will be?
Okay, they will be writing now.
Good.
What are you gonna write? What do you have to write?
I want your impression about the video conferencing, how it helps or it doesn't help, whether it is good enough or not. Anything that you can think about this, the video conferencing, not about the course. The course we have no problem. I'll get you a formal assessment pretty soon. I mean, I don't want the history of your life, just few lines, you know.
We got like at 6 o'clock this morning. You have been writing them all night, or?
Well, I had to do a lot of scanning. This is, you know, it has a lot of diagrams and stuff. But this time I got something else for you. Well, you'll see in a minute. You see? You know what this is?
Yeah.
You'll see me writing here.
No.
No.
Yes. Didn't you, you know, I thought that maybe we should do this way also, so. Annette, yes.
Would you like to tell our students about the Saturday, because we forgot to inform them about next Saturday.
Okay.
We're going to be in Russia.
Okay. Okay. So you want me to talk or you will talk?
I stop.
Okay.
You know what the journalist commented?
What?
That you resemble Hemingway very much. You look like Hemingway.
Well, I hope I don't blow my head. Anyway, guys, the...
However, I think being in a country... No, I was trying to be sarcastic. Is it? Okay, maybe
Annetta, if you dial up, hello? Good afternoon.
I'm stuck at the wrong.
Thank you.
Благодаря.
No E? Yeah. Clara. But it connects. Why? What's the problem? It's just, I know, but it's like there's a pause, and then it's like, yeah.
You guys must have a lot of fun there. Τελικά δεν μάθαμε πώς μετακινείται η εικόνα. Δεν μετακινείται τα χρήματα. Όχι, εντάξει. Να τη βγάζω, θέλω και εγώ να τους βλέπω, αλλά μάλλον τον εαυτό μου και να τον βγάλει την λίγο αν γίνεται. Και μετά... Ωραία, πολύ. Λοιπόν, αυτοί πρέπει να μας ξανακαλέσουν.
Θέλουμε να κάνουμε συνήθως στα 3 κανάλια.
Το βάλαμε το βίντεο, έτσι.
Γράφει τους ή άλλους τώρα.
Εντάξει, ας γράφει. Είναι καθηγητής ανατομίας του. Yes, I see the newcomer. Hello, how are you?
Very well, thank you.
Professor Marinov, good afternoon. I know I saw you, but
I wrote a novel.
we are having a good... Yes, greetings.
Very well. Okay.
Okay, everything is very fine. Annetta? Annetta?
Yes, please.
Maybe you should tell the guys to dial up the 3 channels. And then we can... No, this is only one that you have.
Yeah, that's the only, but because it's perfect, we don't want to destroy it.
Okay, no problem. If you feel that way, and you don't want to see plasticity in my dance, δεν κλείνει το στόμα της. Τώρα θα μας πάρει να ξανά. Όχι, εντάξει, δεν χρειάζεται. Παιδιά, εντάξει είμαστε.
Πολύ δυνατά μου φαίνεται.
Δεν πειράζει, εντάξει. Ναι, ακούγεται βαβούρα, αλλά δεν θα μιλάνε ότι θα μιλάω.
Απλώς και πριν έτσι πως ήταν, νομίζω ότι δεν ακούγονταν η
Ναι,
κάμερα.
γι' αυτό καλά κάνεις και το ανέβασες. Δεν υπάρχει.
Αυτά είναι τα κουφά του συστήματα.
Βγάλε το μούτ,
Ναι, ναι.
Τώρα θα δούμε. Ότι κάνει connect με 2 και 3 ή αυτόματι το κάνει. Φαίνεται για 3. Ναι, φαίνεται πιο πλαστικά.
Ναι, η κίνηση ότι δεν είναι την κάρτα.
Hello. Βγάλε την εικόνα, μπράβο. Hello. Hi. Now you see things are a little bit more smooth, right? Well, I can see you a lot smoother. I don't know if how you see me.
You look handsome.
Thank you. So, I can, whenever you are ready, tell me what you need and I can start, or I see we have a lot of people learning physiology today.
The press has arrived and we're waiting for some more people from the TVs and the...
I see, okay, no problem.
And for Professor Cristaldo and now Vice Secretary.
Very nice.
Do you want to hear what they have
Γιατί
written?
είναι...
Oh no. You're good.
Φωτογραφίες.
Oh, no, go right
Τώρα
now.
θα είμαστε κομπλέ.
That sound I can recognize.
And it is, some of the students want it to be confidential.
I'm good.
Confidential.
How are you?
Okay, thank you. I have to be fine.
Νάτι. Να, ο καθηγητής φυσιολογίας είναι αυτός φαλακρός εκεί πέρα, να πούμε από εδώ. Hi, Ανέλια. Αυτή είναι η πρίτανη στο πανεπιστήμιο, είναι γυναίκα, είναι πολύ καλή. How are you today?
Very good, I'm happy to be here.
Professor Negrev, how are you? Φυσικά δεν ξέρει. Γκρι αγγλικά αυτός, γι' αυτό και κάνει το μάθημα. Είναι καθηγητής, οι φυσιολόγοι τους δεν ξέρουν κανένας αγγλικά, είναι όλοι της ρωσικής σχολής.
I told you.
She's your favorite.
Who am I talking about?
Huh? Gogi. Cockroach, yeah. Right?
Huh?
What's the name, Gogi?
Don't say.
So, can okay, should we start on the next round, or what is the story now? I see a lot of people there. Oh, beautiful.
Questions about the lines and what it's all about.
Okay, that's excellent.
Tell them a few words first in Bulgarian.
Yes, please, please. I'm waiting for you.
What?
We're negotiating that.
Yes, you can title it. Βλέπετε όταν έρθει το offline. Τίποτα. Δεν έχουν βάλει καλά τα μικρόφωνά τους εκεί. Δεν έχουν directional. Μα έχει πολύ κόσμο μέσα.
Имаме специално вече оборудвана зала. Искахме да видим как работят залите с две. Да. И тази връзка в момента, която виждаме, тя се ще от 9:30 сутринта. И опитахме да ги направим по същия начин, както нашите работни студенти. От 9:30 до 12:30 с една почивка до 20 и от 2 до 5. Темата на днешната лекция беше поредната в учебния план с нашите студенти, те са първи курс. Професора Ноанакис води курса от самото начало, лекционния курс по физиология и днешната лекция, днешните серия ден е посветена на въведение в сърдечно-съдовата система. За бъдеще се надяваме, че такива връзки ще има, например, професор Ноанакис има студенти от катедрата по физиология.
She's saying a lot of good stuff.
Yeah. Listen. Give her a kiss for me.
Yeah, very good thing.
Тези инструкции могат вече да четат и по една такава конференция.
Δες μας, μου έχουν δημιουργήσει μέσα. Και βλέπεις έρχονται και μου ψιθυρίζουν στο μικρόφωνο πράγμα.
Τώρα είναι πιο ζωντανή. Τώρα είναι πιο ζωντανή.
Както и с останалите университети в България, но и в целия свят. Защото ние имаме партньорски институции, които поддържаме и лектори идват на обмени на права. Можем много време, много енергия, много усилия и много пари.
Колко струва това? Точно това ще разкажа.
Тези въпроси They are discussing how much that will cost for one day. And to check if you can do that at the university.
I can give you an answer that the cost for one day is less than one trip by aeroplane one way from Sofia to Varna. Of course, Aneta, of course, if you want me to stay there, then of course it's expensive because then I don't have, you know, I won't have money to come back with just the money you spend.
And now maybe we give the floor to Professor Kristarova, our rector, to say a few words. Why not? Why not?
Аз много се радвам, първо, че започнахме тази програма.
Professor Kristarova is very happy, first of all, because we started this program.
Започнахме тази програма, но особено съм щастлива, че в тази програма те нашите усилия, които ни вложихме, се включват и много други наши колеги.
Even more delighted that in our efforts, our colleagues, many of our colleagues got interested and got involved.
Аз искам най-искрено да благодаря на професора Ноанакис.
Professor Kristarova would like to thank you from the bottom of her heart.
Защото тази идея на телематична връзка, тя не е толкова нова.
The idea of a telematic network is not new, and you are one of the initiators.
Още когато аз не бях ректор, как като заместник ректор, имахме срещи с професора Ноанакис, но обсъждахме възможността не само за обучение на студенти, а и за практически занятия по този начин.
And it was many years ago when I was still not the rector, I was the vice rector, when we discussed the possibilities of having lectures online.
И това беше възможно тогава, беше възможно и сега. Но искам да кажа, че професора Ноанакис е съвсем специалист в
that Professor Ananakis, apart from being an expert in physiology and professor in physiology, he has special interest in telematics, and he is a very good expert on that too.
И благодарение на този негов интерес, на тези негови познания, ние направихме тези крачки напред. И нашия университет, в първите университети, макар и не медицинския, не технически, който използва тази техника за обучение на студенти.
And our university is one of the first ones, even not a technical, but a medical university, thanks to your interest and thanks to opening our interest to not and your opinion and your advice to start having that lecture.
Това стана благодарение, разбира се, и на всички мои колеги, които аз не съм
It was made possible to happen thanks to all my colleagues who are present here, whom I invited. To the Dean of the Medical Faculty, Professor one of the main driving forces of the program, also a lecturer in anatomy, Professor Marino. Special thanks to Mrs. Petrova and to her assistant Svetla, who were the mediators with the Bulgarian telecommunications company.
Те направиха голямо реверанс към нас, защото ние ги попитахме, те отговориха, че ще отклики и наистина ни помогнаха да го направим.
They were extremely collaborative, they were very kind, and they took all this to heart.
И за това смятам, че когато се включат толкова много хора, нещата наистина стават хубави.
And I think that when so many people join there, the first thing really happens.
Защото така и на нашите американски студенти, нашите студенти по американската, по английската програма.
And also I would like to thank to our students in the 4-year English program.
Защото те са първите обучавани.
Because they are the first ones to be taught in such a way.
Аз и специални благодарности на Ани, доктора, която е сърцето на програма.
And to me, of course, this is Anita Dokova, who being the heart of the program.
Well,
give our kindest thanks to your assistants over there in Thessaloniki University.
И аз нашата цел е, това е първото начало, но това непрекъснато да се разширява. Възможно да поканим и други лекции за Солунския университет, защото има наистина водещи специалисти, които колаборират много добре с нашите катедри. И ние можем да правим не само учебни, но и научни такива конференции.
And Professor Kitarova is saying that this will not be a single act, and we insist that it goes on and it becomes a tradition, and we widen this because there are professors at Thessaloniki University with whom we have, in other departments, with whom we have very good relations, and we hope that this program will not only be for academic training, but it can also be for scientific research.
Разбира се, не бива да забравяме, че един медицински университет или това може да даде началото на една чисто практична телемедицина.
And we shouldn't forget that this is just the beginning, and we are just laying the foundation of the future telemedicine, and we can use it for practical medical programs. Thanks a lot. Special thanks from Professor Kristalin.
thank you very, very much for all the kind words. And can I say a few words myself?
You do.
Okay, will you translate for me?
I promise.
First of all, I want to thank everybody for this warm reception. In fact, we are in the same room. This is a room 1,000 kilometers long and only a few meters wide. I want to say that your university has bestowed the highest honors on me all the time, and it is my duty to support either from being there or from the distance, and I am really grateful to all of you. I want to thank especially Professor Klisarova, who is the rector, and Professor Negrev, who is in fact the person responsible for me doing this thing here, because he is the professor of physiology, and Professor Marinov, whose science is the sister science of physiology. I am sure that I miss all the other names that are there, but thank everybody. I do not miss because I want, just because I don't know names or I don't see some faces. I will take the opportunity to invite the professors there to also give lectures to Thessaloniki through the same channel. And we should arrange that the fastest possible. And I wish good luck to the application to the European Union for funding, and we're going to do our best to see it through. Thank you very, very much, all of you. Aneta, I just want to add one thing. This is not going to be an excuse for me not to come. On the contrary, it will be a good reason for me to come more often.
Very good. Say it again.
And I say this because I have some of the best students and most warm students, and I really want to thank them from the bottom of my heart for the reception I received from their ears to what I have to say. They are really great. They are going to really make some of the best graduates of your university. I can guarantee you that.
Thank you, George.
Thanks, George.
Thank you, guys. Okay. Excuse, what about the 4th of September?
The question was when the next video session is going to be. And it's going to be on the 4th of December with you and them.
That's fine. The 4th of December is okay, despite the fact that it is a very heavy day, but we are going to do it.
Well, if you want to change it, just
No, we'll talk about these things, you know, the 4th is okay, don't worry. 4 Δεκεμβρίου, τι μέρα θα είσαι?
Now we have taken enough of your time for the lecture, and I would suggest that you get down to work.
Okay. Annetta, the only thing I would appreciate if when we finish you call me so that I give you the latest about Brussels.
Right.
Okay.
Thank you very much. Okay.
So,
Wish you good luck in the next lecture.
thank you very much. Now can we get on with the lectures? Good. Βγάλε το slides. Bye bye. Άσε να με βλέπει. Γύρισε. Hello. Anelia, goodbye. Professor Marinov, goodbye. Anelia, goodbye.
Auditory number 3, okay?
Bye bye. Bye bye, Professor Negrev.
Yeah. It's going to be tonight on MSAT and something Rana tonight. Why not?
Okay, guys. Now that the storm is over.
Yeah, we're on MSAT 10 o'clock.
Oh, where?
MSAT. We will be.
Which channel is that?
Can we go on?
It is? Yeah.
Hello?
What channel are we?
Hi, can we go on?
Okay, I'm right here.
Yeah, sure.
All right. So, now we are going to, I'm going to ask you one last time, what we said this morning, is it clear? Or mostly clear?
Yeah.
Okay. Because we're going to talk about the electrocardiogram. Who can tell me what an electrocardiogram is?
Estimation of the electrical activity of cells of the heart.
Myocardial fibers, right?
Myocytes or myocardial.
Okay, good. That's good enough. Okay. Now let me tell you that this is very, very deceptive. In order to take the electrocardiogram, you take one wire in one of your hands, another wire in the other, and if you plug them into an oscilloscope, you are going to see something that indicates what your heart is doing. So that it is the summation and all these things, this is just preposterous. We just think it is that way. We're going to see why we think it is that way, okay? But it's not that simple. I prefer that if somebody wants to describe the electrocardiogram, describes it as the recording of the activity of the heart from the surface of the body, okay? Was that clear? Yeah. Okay. Now, how good is your physics background, first of all? How many people have taken some physics? All of them. All of you?
A long time ago.
It doesn't matter. It doesn't matter. I'm not going to ask you to solve the fusion equations for helium. Okay? So, I need just basic ideas and basic concepts. Okay. Now, the description that we have about the cardiac function is based on a few concepts. The first of all is the concept of the electrical dipole. In fact, it is this concept that has been with us since the beginning of last century, the beginning of the 20th century, and it is this concept that has permitted us to resolve all the problems with the cardiogram. Secondly, we're going to talk a little bit of why it is this electrical activity modeled by a dipole. The third, we're going to talk about a concept that it's called the instantaneous... Hello, can you listen to me or you have a problem?
George, 1 second, we have just like some technical difficulties.
Sure, 5 seconds, no problem.
Yeah, just give us 1 second.
Βγάλε να με βλέπουμε κιόλας.
We have some technical difficulty, but we will be back.
You will be back?
You know, in the news when they do teleconferencing,
Yes?
especially BBC or CNN, sometimes they lose the connection with some generals or something.
Yeah?
On the news.
On the news.
Anyway, you'll all be on the news and TV tonight, so you call CNN Bulgaria, you'll call CNN Bulgaria and your relatives are going to see you over in the United States and Canada.
Oh my God. I hope so.
I don't know, but
Yeah.
it seems that they have a lot of fun with this thing there.
Really?
Shut up. They were on TV? Really?
Yes, you're going to be on TV, that's what I understand.
No, actually we're going to be like in 4 or 5 channels tonight.
Well, whoever has a video, make a videotape for me too.
Don't you have a VCR?
Do you have a video?
No, I cannot record it.
Oh, we'll tell Anita to make one for us actually. That would be nice.
Yeah.
We'll tell Anita.
Well,
Because I don't have...
one thing I'm going to tell you, next time that I come up there, I'm going to take you all out to dinner.
Oh, thank you.
Okay? So we're going to have some fun also, you know.
Yeah, that would be nice. Or we haven't tried Greek food, remember?
Don't worry.
We should take some Greek restaurants.
Well, this is not that difficult. We're going to find Greek food. They have a lot of Greek food up there.
Oh, I missed the lamb chops here. Lamb chops?
Did you hear
Yeah?
what I said?
Huh?
He goes McDonald's with the Greek salad.
Yeah, you're right. McDonald's is just as big in Greece nowadays as anywhere else.
Actually, McDonald's is more expensive.
So what was the technical problem anyway?
Oh, the slides here. We cannot see the slides.
The slide projector.
Oh, I see. Δεν έχω projector, αίσβησε η οθόνη τους. So you cannot see me now or you do?
We can see you.
We can see you.
We have the slides set up separately.
Έχουν το άλλο, το τοπικό, ναι. Well, I can put my slides up for you, there is no problem.
No, we cannot see them very clearly. Yours aren't that clear because the TV screen is really small. Are not very clear. So
Mine are very small?
Yeah.
Okay.
It's not small, the text is not very clear.
Okay.
Oh, we got it.
Well, these are the kinds of things that I want you to write down for me.
We're back.
Okay, good. All right. So now,
Okay, electrical dipole.
right. We said we're going to be to describe the concept of the electrical dipole, why we needed to model the myocardial cells, what is the instantaneous electrical axis of the heart. This is something that most books just go over it very lightly. However, it is the basis of everything that you're going to see, and it is important you understand what you're talking about. Then we're going to talk about the average electrical axis of the heart, and finally about the conventional electrocardiogram, which is based on all the other things, but which we don't talk about. We talk only about the electrocardiogram when we talk about patients and so on. Okay? So, let me show you what is a vector. A vector is a mathematical concept that combines direction and size. So a vector is basically a way to describe a magnitude with a direction. And because electrical fields are described with vectors, this is why I put this little diagram up there, so which shows you how you add two vectors. In order to add two vectors, you have to slide one parallel to its original position, bring it to the same origin as the second one, or to a common origin, and then proceed with the rule of the parallelogram, as it's called, to add them up. So if you have vector A on top and vector B at the bottom, you can slide them to a common origin and take A plus B as their total, as their combined, as the combined vector, okay, as their summation. Now, why do I say all that? Why do we need that concept? Well, you need it for one simple reason, that if you look at what we said about the way the cells are lined up on the walls of the heart, and if you recall this on the left-hand side, this is the original picture that I had shown you about how the two cells are connected to each other, or any two cells are connected to each other in the myocardium. And if you take on the right-hand side an area of that cell, and we suppose that it is active. In other words, you see there that there is a depolarization because the internal environment has become positive. This is depolarization, right? Normally, if you recall, the internal environment of the membrane should be negative, correct? Then if you have an action potential, and that is the place where I have between the two red lines I have the two pluses, then obviously you are going to have field lines which show you how the current is going to go from the non-active to the active areas of the cell, okay? And if you recall, this creates a depolarization which makes the action potential move to, and in the last slide, this is the left-hand bottom slide where you have the first movement, and then of course when it reaches near the next cell and there is a cytoplasmic bridge, then some of the field lines cross to the second cell, so they depolarize that. And this is how the action potential moves in the heart from one cell to the other, okay? We have already described that. I have this thing here so that we can go to the next slide, which shows you really why we need vectors to describe each of the cells. Here I take one of the two cells so that I don't make a very complicated picture. And you see that as you have an area that is excited, you're going to have a strength of a field that in one way is longer, is bigger than it is on the other. If you notice in the first picture, there are more negative sides next to the negative points next to the action potential, before the action potential actually, then there are after it, so it is logical that the place where the action potential is taking place will draw current much more from what is in front of it than from what is behind, correct? But as this action potential moves, the field also changes. Then you see that the vectors change in size, and on top with not with the orange but with the red color, you see the net vector. So there is a point in the cell where once the action potential reaches, this summation may go to 0, and then it will reverse as you see in the other slide, that it is on the left-hand side on the bottom. So what you see here is you see how an electrical vector that represents the electrical activity of the cell changes as the action potential moves from the left-hand side to the right-hand side of this cell. Is this understood?
Yeah, but how the direction change? The direction, I mean, why the direction change?
The direction of the move. No, the direction of the vectors change because you see, take the first one on top, the first left-hand side on the top. There is one negative sign on the one side, which means there is less area negative than on the right side of the action potential, correct? The action potential is where you have inside the cell the pluses. This is the area that is active, correct?
Yeah.
Yeah.
So the field lines to the left side are going to be much fewer than to the right side. Isn't it logical? You have a lot of more place to draw ions from to make your current on the right hand side than you have on the left. Is this understood why? Well, you have a bigger pool of membrane on one side than on the other. So it's logical that this is where you're going to draw current. So the vector that shows you how the electrical current flows is going to go big one on one side, to the right side, small one to the left. The average, the summation, is put on top with the purple or the red vector. This is the summation of two vectors.
The purple, the pink one.
The top one. Then as the action potential moves down the line, goes farther to the right, then these two areas, right and left, become pretty much equal. They are not exactly equal, okay? And so the summation vector is smaller. And then it will reverse itself when the left side has many more negative charges than the right side. I think that this is reasonable, isn't it? To say the least. I'll take you back a step to show you how the flows are. Remember here, as you move, the blue lines show you where the currents come from, right? So this is what happens. So if you have more negatives on one side, you are going to have more current comes. I just didn't exhaust myself writing all the current lines with blue, but there should be similar current lines going all the way down. Like over here on the fourth picture, that is the bottom right, where you see that the lines can also come from the neighboring cells as long as there is communication. I see you very perplexed. If it is so, I'll download from the internet a very small thing about currents and send it to you.
Okay.
That'll be fine.
Okay, because basically what it says, that you can draw currents from the places that they have ions to send you, to carry them. So if it is on the right side or on the left side in our picture, the vector will be accordingly, bigger or smaller. Are we clear now? Or at least partially clear?
Yeah.
Okay. Now, what happens in the heart? As you see, at any instant, every cell can be represented by a small vector that represents its electrical activity. I go back again. Remember, the top vector in all three cases represents the electrical activity of that cell. Correct? In other words, whether it is excited or not, because if it was not excited, then that vector would be 0, because inside would be only negative and there would be no current flowing, correct?
Yeah.
And then as it moves, then it points one way, which shows that the one part of the cell is inactive versus the other, and then it reaches the middle and arrives all the way at the back. So the way the vector moves is in effect, it shows you the condition of the cell. Right? This tells you something, that if the cell is active, if the action potential is in the middle of a cylindrical cell, then whether it is active or inactive will not be able to tell, because the vector will become 0 at some midpoint, and at the same time, if it was not active at all, still it would be 0, right? I hear only one answering, and that one seems to know some physics. So, can I ask you for help to explain to the others what you understand?
Each cell has its own vector, its own magnitude of current that it's drawing, and if there's not the polarization, then there is no vector. So after that, you summate all the vectors together, I think. And that's the rest of the explanation.
Oh, you want me to put it on the board for a minute? Okay. Let's see if you can see me on the board. I'll walk to the board here. Hi. Again. Okay. All right. All I'm saying is that if we... Can you see me there? Can you see the lines that I'm drawing or not?
Yeah.
Okay. All I'm saying is that if you have a cell, remember that we talked about having cylindrical cells? When we talked about nerves and so on?
Yeah.
Okay. We said that an action potential is one part of the membrane that becomes very active. Okay? When it becomes active, it means that it reverses its current, becomes the inside positive rather than negative. Correct?
Correct.
Okay.
Yes.
Remember that we said that it crosses over and it becomes...
Yep.
You remember that, right? Okay. Now over here, the level is very low compared to 0. Over here it's up here, and over here it's again low compared to 0. So, simple.
Sorry, what was that?
This is the action potential, this is the resting potential. So the resting potential is negative, and at the point where you have the activity, the resting the membrane potential becomes positive. That's all I'm saying.
Okay,
So
it's hard to hear you, that's why.
Excuse me?
It was a little
When
bit
you
hard to hear
turn
you.
to the board, we cannot hear you very well. But
Okay, no problem. I will talk this way. All I'm saying is, as you move away from the place where the action potential happens, the rest of the cell is in resting potential. Only here reverses potential, correct?
Yeah.
Therefore, currents are going to flow from the inactive areas to the active, which means that this area will depolarize, cross the threshold, and give another action potential here, correct?
yeah.
And then move down, and then move down. Remember when we, in the case of nerves, we talked about unmyelinated fibers and myelinated fibers?
Yeah.
Okay, the same thing holds for these fibers.
Yeah.
Okay, so all I'm saying is that now if we represent this, let me be this way so I can talk to you. If we represent this, if we cut this and we look at the inside, okay, you're going to have currents going this way. and because you have a lot more place to draw currents from this side than you have on here, the vector that represents this difference between this and that is going to be much smaller than the vector on this side. So the net vector is going to be the difference between the two. As when this arrives in the middle, these two areas will be equal. Therefore, the vector will become 0. And when this area comes out here, it will happen to go inverse.
Now I get it.
Okay, is it understood now?
Yeah.
Okay,
That was
so
better.
all I'm saying, for every cell, there is one vector at all times that represents its state. The only thing I have to tell you is, the only thing that it has to be, you have to watch, is that when this thing is exactly symmetrical here, when it's exactly symmetrical, the vector will be 0 the same way that it will be 0 as when there is no activity. That's all I said.
Okay.
Okay, are we clear on that now?
Yeah.
Yeah.
Okay, now we are going to continue.
Кажете му, моля, да се на професора. Помолете го само за секунда да прекъснем връзката, ако е възможно. И да минем на един канал.
What?
They want to change to one channel.
Okay, no
Може да
problem.
прекъснем и да минем на един канал.
No problem.
Извиняваме се много. Да. Добре, само за секунда.
Okay,
Ще прекъснем.
Only a few seconds.
no problem. And listen, the first time is always difficult.
And if there was no action potential at all, it was 0 as well. Yeah. They have both.
Hello?
Get it first.
Yeah, we're here.
Okay.
I can hear you.